Hi, in this video we are going to talk about the main differences between linked lists and arrays. So, let's get started. What's the difference between these data structures as far as the search operation is concerned? The search operation yields the same result for both data structures. So if we are looking for something, it's going to return the value if the given data structure contains this given value, or anyways, it's going to return null, for example. ArrayList's search operation is pretty fast compared to linked list search operation because we can use random access for arrays. So the get item is going to be very fast because we can specify the index, which is going to yield ordo 1, so constant time complexity operation. On the other hand, linked lists has ordo n, so linear time complexity as far as the performance is concerned, because we are not able to do random access for linked lists. So if we are looking for an item, we have to start at the root node. It's very important. I have mentioned it several times. But for linked lists, we are able to access the root node. So we have to iterate through all the list and basically have to check on every iteration whether this is the item we are looking for. And of course, in the main, it's going to take linear time complexity. So the conclusion is that ArrayList is better for this operation. You may pose the question that, okay, why? Because ArrayList maintains index-based system for its elements, as it uses array data structure implicitly, which makes it faster for searching an element in the list. So if we know the index of the item we are looking for, it's very important that it's true if we know the index of the item we are looking for. If we don't know the index, then we have to iterate through arrays list as well, and the operation is going to have ordo and linear time complexity. Searching for ArrayList is going to be very fast if we know the index of the item we are looking for. So linked list requires the traversal through all the items for searching an element, and that's why the search operation is going to take linear time complexity for linked lists. Okay, what about deletion? Linked list remove operation takes ordo 1 time if we remove items from the beginning of the list, and usually this is the case. This is why we like linked lists. On the other hand, for array lists, removing the first item, so if we want to remove items from the beginning, it's going to take ordo n, so linear time. And removing the last item takes ordo 1, so constant time. So it's very important to see the difference that for arrays, it's very fast to manipulate the last items, whether it is about removing or inserting an item, but manipulating the beginning of the list is going to take ordo and linear time. For linked lists, manipulating the first item is going to take ordo 1, constant time complexity, so very fast, while manipulating the end of the list is going to take linear time complexity. So for arrays, on average, we have to reconstruct the array when removing an item in the main. So for example, if we would like to remove items from the middle of the array, of course we have to reconstruct the array. So the conclusion is that linked list is better as far as the deletion operation is concerned. Okay, why? Because linked list basically operates with pointers. So the removal only requires changing the pointer location, which can be done very fast. For arrays, we have to shift all the items, and that's why it's not going to be as fast as for linked lists. What about the memory management? Arrays do not need any extra memory because we are not going to store references to the next node. Linked lists, on the other hand, do need extra memory because of the references or the pointers. So in this aspect, arrays are better, they are memory friendly, so we don't have to store extra pointers to the next node or the previous node for doubly linked lists and so on. So array lists are memory friendly, linked lists are not so memory friendly. So just to summarize again, what about the search for linked list? It's going to have ordo and time complexity. For arrays, if we know the index we are looking for, it's going to take ordo 1 constant time complexity. What about inserting items at the start, so the beginning of the list? For linked list, it's going to have ordo one-time complexity. For arrays, it's going to have ordo n-time complexity because of the shifts we have to make. What about inserting at the end of the list? For linked list, we have to iterate through the whole list. That's why it's going to have ordo and linear time complexity. For arrays, we are able to insert it in constant time complexity because of the random indexing. What about the memory management or the space we waste with the help of these data structures? For linked list, we have to store a reference to the next node as far as every node is concerned, so that's why the memory complexity will have ordo n, so linear memory complexity. For arrays, we are not going to store any extra data except for the data we would like to store, of course. That's why the waste space will be 0. So, according to this table, we can decide what data structure to use in a given application. It depends on what operations we would like to use frequently, whether we would like to insert at the end of the list or at the beginning of the list, whether we would like to search according to a given index, or we would like to search for an item where we do not know the index. So basically, according to this table, we are able to get the data structure best suited to the application we are going to implement. So that's all about the differences between lists. Thanks for watching.